So hello everyone, welcome to week 2 of the CAD and 3D printing milestones course. Today we're going to kind of be expanding on what we learned last week. So, we started making sketches, we used kind of the basic extrude and revolve tools. But this week we're going to kind of work on being a little bit more intermediate and creating more advanced sketches. So last week, I talked a little bit about constraints. The big one that we used was what we called the dimensional constraint. So, it's just setting some distance or some angle between, two different things. But there's a bunch of other constraints that we can utilize. We used some last week, but today we're going to be a little bit more specific about, what tools are available to us and why we might want to use them. So constraints, allow you to define the sketch. Typically our goal is to make sure the sketch is fully constrained before we move on. That just makes sure that the geometry is exactly what we want it to be, and it also allows us to modify it later. So using constraints, you can relate different parts of it to fully define it. Depending on the constraints you use, you can kind of narrow down which constraints or dimensions that are important and which aren't, so you can avoid like undesirable modifications. So that's kind of what we're going to be doing today. There's a bunch of different constraints here. These are what we call geometric constraints. So most of these red icons that you saw last week in the sketch toolbar are geometric constraints that we're going to utilize. Most of these, if you've taken some kind of geometry class, are pretty self-explanatory, like parallel and perpendicular and stuff like that. But there's also extra stuff that might be a little bit new, like coincident and midpoint and stuff like that. So I'm not going to go over all of these right now, just because the demo probably speaks, the demo is a little bit more efficient to kind of understand how these work. But I will say there's the fix and unfix constraint, the one with the lock. We're going to teach you how to use it today, but I will tell you now that it is usually best practice to avoid using the fixed constraint. Just because when you're using the fixed constraint, you're basically locking in some kind of arbitrary dimension. So you saw last week, you can like drag around the rectangle if it's not constrained. If you apply a fixed constraint, it'll lock it wherever it is, but it's not exactly precise. So it's a tool that's available to you, but I highly encourage you to not use it ever. In the many years that I've been designing stuff, I've only used the fixed constraint in one really, really specific scenario, and that's not really something we're going to cover in this course, and it's not something you're very likely to come across. So in general, please don't use the unfixed constraint. We're going to teach you how to use it, but it's not the best tool for most scenarios. Also, if you do use it, the color of the line changes, or the color of the vertex or whatever changes, so I will know when you're using it. So yeah, just don't really use it, except for this assignment that we're going to do. Here are a couple more geometric constraints for you to see. Horizontal and vertical is very useful, along with the tangent one. I use those a lot, especially with the equal one. So you're going to get pretty familiar with a lot of these. So yeah, we can just jump right into it with the assignment 4 with these geometric constraints. So what you're going to do is you're going to download this file, which I have sent to everyone on the Discord. So if you go under resources, there's this geometric constraints Fusion file. You're going to want to download it, and then we're going to upload it to Fusion. open the chat real quick, just in case anyone has any questions. Also, if someone's having trouble finding this, please yell at me so I can help you. Okay, so assuming that everyone's downloaded it, what you're going to want to do is you're going to go into the data panel to upload the file. So if your data panel is hidden, you can click that array of squares and it should open. You know, put it wherever you like. I kind of put it in a little project folder with all the assignments we've done so far. I'm just going to select upload here, find the file, and then upload. And then we're going to open this up. Okay, so I'm going to give everyone like 1 minute to kind of get here. Just want to make sure everyone's here. If you're having trouble, please speak up now so I know.
Could you go over how to upload it again?
Sure. So if you've downloaded the Fusion file already, you're going to want to open your data panel. You know, if you're in the home area, then you kind of go under whatever project you have all your stuff under. I have a bunch of folders. And then here you just select upload, select files, open your file explorer, and then you should be able to upload it.
Okay, thank you.
Does anyone else need clarification before I continue? Okay. I'm gonna assume everyone's good. All right, so now that you have this file open, you can kind of see here, there's an image with some text on it, and then a bunch of, you know, lines and circles and stuff like that. So what we're gonna wanna do is we're gonna wanna edit the sketch that contains all of these geometries. So we're not gonna create a new sketch. We're gonna go into the timeline here on the bottom, and then there's a sketch here. It's called Sketch 2. So we're gonna right click it, and then edit the sketch. And now we should be able to manipulate all the lines and circles here. You can see I can drag this around. Right? If you made a new sketch, you won't be able to manipulate these things. So make sure you're editing the current one. So what we're going to do is we're going to kind of read whatever these instructions say, and then we're going to apply the constraint that it's asking for. So I'll do a couple, and then I'll let everyone kind of try it themselves, and then if we're having trouble on some of them, then I'll just do it in front of you so you understand. So for the first one, I'm just going to start in the top left. Here it says to make these two lines perpendicular. So what I'm going to do, there's a couple of orders in which I could do this, right? You can hold shift and then click on the two lines and then apply the constraint, or you can or you can select the tool and then apply that constraint. So I'll do the second one I just said first, and then I'll do the first one on another problem. So here I want these two to be perpendicular. I go up here under the sketch toolbar, and there's this perpendicular constraint. You'll notice that all the geometric constraints are all like red tools. So if you're looking for them, look for red. I'm looking for perpendicular here, so I'm going to click on that, and then I'm just going to click these two lines. The next one, it says to make these three parallel, but you'll see next to my mouse there's kind of a small perpendicular icon. So if I click on two lines right now, it's going to make it perpendicular. But what we're going to want to do is we're going to want to make sure we're in a different tool. So you can either press escape and to leave the perpendicular tool, and then you can enter in another tool. In this case, we could do parallel, right, which is also right here. So we can do that, make these two parallel. If you want to do the shift click method, then I'm going to press escape to leave the parallel tool, and then let's make these two parallel, right? So I'm going to hold shift, click these two, they'll get highlighted, and then I can apply the parallel constraint, and it does the same thing. So, I'll give everyone maybe like 5 or 10 minutes to kind of work on the rest of them. And if there's a specific one that we need help with, just holler out, and I will do it for everyone. Also, while I wait for this, I will be back in like 5 minutes. I have to use the restroom. All right, I am back. So if anyone has any questions on a certain problem, I am happy to do it now.
Yeah, could you explain how to do the last one?
The one in the bottom right?
Yeah.
Okay, sure. So there's technically, I guess, two correct answers for this. There's one that I kind of prefer over the other. It says here, line up the centers of all the circles on the same horizontal plane. I have noticed some students just make all of the circles, wow, I'm blanking on the word right now, concentric, right? And that's technically correct. But the preferred answer is that they're all on kind of like their own horizontal line or like an invisible horizontal line, and the points are not all in the same spot. So I'll do the preferred method right now. And this is kind of a good one because it shows some things that you might have to do to make Fusion kind of create the constraint that you're looking for. The main thing about this is Fusion combines both the horizontal and vertical constraint into one tool. So it'll do what it can to apply the constraint that you want. But sometimes when you have, points in certain spots, it may not achieve the behavior you're looking for. So in this case, we kind of want all of these to be on a horizontal line here. So if I just create a vertical constraint between this point and this point, or a horizontal vertical constraint between this point and this point, it'll kind of snap to the vertical, which in this case is undesirable. And the reason for this is because Fusion will kind of apply the closest constraint to achieve, whatever you're asking for. So for horizontal vertical, because these 2 points are closer to vertical than horizontal, it's going to apply that and be vertical. So in some cases, if you're not getting the output that you're looking for, you might need to kind of massage your sketch a little bit to encourage Fusion to go in the right direction. So, in this case, if I massage it this way and move this circle, it's going to do, the opposite of what I want because they're both very close to vertical. But if I move this circle over here and I do the same thing, now they're both horizontal. And then if I apply the same thing here, should be good too. So that's something to keep in mind. Sometimes, that'll happen with the vertical or horizontal constraint. Sometimes it also happens on the tangent constraint, and it'll go tangent to the other side of the circle or arc that you're trying to constrain to. So it's a good thing to keep in mind when you're creating your sketches.
Thank you.
Yeah, no problem. Is there any other problem someone's looking for a little bit of help on?
Could you explain the first one on the second row?
The one with A, B, and C?
Yeah.
Sure. All right, so this one says to fix point C, make the endpoints A and B coincident with point C. So these letters are kind of labeled like in a sad area, but basically we want to constrain, one of the ends of these lines to the center of C. So I usually pick this one up here and this one. And then before we do that, we need to fix point C. So for circles, you can constrain them either at the point or on kind of the radius or diameter. In this case, it's saying point C, so we want to constrain this point here and not the outside. So I'm going to use the fixed constraint, and I'm going to select this center point here. You can see the center point changes colors. So again, when it turns green, I'll know. And then for these, I'm going to constrain point A to here. So I'm going to use the coincident constraint. Select this endpoint and this one. And then I'm going to select this one and that one. And then that's what it should look like. The letters don't really follow the lines because they're just kind of floating there. So this is perfectly acceptable.
Thank you.
No problem. Any other questions on any of these? All right, last call for any of these problems. If not, then we can just move on to the next assignment. If you haven't finished this, then no worries. You can finish it after class. It shouldn't be too bad. And again, you're welcome to ask me questions after class as well. All right, nothing? All right. Okay. So now that you have a better understanding of geometric constraints, we're going to utilize them to create our next assignment, which is this gear. And then we're also going to add a couple other tools into your tool belt. So we're going to learn how to mirror stuff, we're going to learn how to pattern stuff, and we're going to learn how to make holes. So I'm going to be done with this. I'm going to create a new design real quick. It's just going to be a part design. And all right, so now that I've created a new file, I'm going to start with a sketch. In this case, the plane doesn't really matter. I usually prefer the top plane for something like this. So I'm going to select this one, and I'm going to start sketching some geometry. So what we could do is, we could make this circle, and then we could draw you know, one tooth, and then we can draw it again and again and again until we have a, you know, a gear. But that's kind of a lot of work, and that makes, you know, things more difficult to change later on, especially if they're not constrained in relation to each other. So, you know, typically all the teeth on a gear are usually the same size and dimension. So what we can do is we can be kind of lazy and we can make one gear and then copy it around the whole circle, right? So in some ways it's lazy, but sometimes in CAD being lazy is actually a good thing, because, you know, it, you know, reduces repetitive work, but it also makes things easier to change later, right? So you can see in this photo, there's a couple dimensions on this top tooth here, and the rest of them don't have anything, but the sketch is fully constrained. So we're going to go for something like that in our assignment here. So I'm going to start with, you know, just a basic circle here, starting at the origin. Again, starting at the origin is good practice just because you have, you know, one fully defined point. You don't need to add any offsets or anything. And then what I'm going to do is I'm going to sketch half of this tooth profile, right? So teeth for gears are usually symmetrical. So what we can do is we can do half of it, copy it to the other side, and then pattern the whole thing. So to do that, I'm going to first start with some construction geometry. So you've probably noticed that most of the lines we've created so far are some kind of solid line. You know, this is a solid blue arc here. When you create lines, it's a solid blue until you constrain it. But we can use something called construction geometry when we're creating stuff. And, you know, it allows us to build some kind of foundation in our sketch. But when we go to manipulate it into something like an extrusion or something, Fusion will ignore these geometries, and it'll allow us to, you know, have more full closed bodies instead. So to turn it on, there's this construction toggle over here on the right. So you can click that to enable it. You can also draw the line regularly and then make it construction later. So I'll do that first so you can see. I'm going to just draw this line here. You can see it's solid, but if I right click it and do normal / construction, you'll see it becomes dashed, right? So that's what construction lines look like. For those who like to use hotkeys, the hotkey for this is X. So, you know, you can toggle back and forth between construction and non-construction that way. So I'm going to use a construction line that runs up the center of the first tooth. So here I kind of drew it diagonally, but I want this to be vertical. So I'm going to apply vertical constraint here. You can see it turns white because it's constrained vertically, so that's good. And then now I'm going to sketch, you know, this tooth geometry. So I'm just going to add 2 more lines. Starting at the top of this line, I'm going to go across, and then I'm going to go down until I hit the circle. So you should have something that looks like this. You'll notice that Fusion kind of automatically gave me some constraints because I drew them, you know, this line relatively flat. If you didn't do that, that's okay. You know, if you kind of, you know, went up a little bit on accident, you can add those constraints back in. So sometimes I purposely draw them like in a quote-unquote like incorrect position, and then I manually apply the constraints later. For me, it's honestly kind of a personal preference, because sometimes, you know, Fusion will make assumptions, and either those assumptions are wrong sometimes, right? Like let's say in this case, I didn't want it to be horizontal, and I drew it pretty close to horizontal, and then it snaps to horizontal, right? I didn't want, let's say I didn't want that. In this case I did, but sometimes it might be undesirable, where it'll give you a constraint that you didn't want, or sometimes it won't give you the constraint that you were assuming that it gave you, right? So last week I was drawing, that rectangle on this kind of red line here, and it looks like it's in the right spot because it is, but it's not constrained, right? And you can move it up and down. So sometimes what I like to do, I purposely draw it away from where it's going to be so I can physically or manually apply that constraint to make sure it's there. I find that it kind of helps with troubleshooting, because sometimes you're like, why isn't this thing being fully constrained? Because it's in the correct spot, but it's missing a constraint, even though it is where it is where you want it to be. So, sometimes I'll do something like this. So I drew it away. I manually apply the constraint myself, and now I know that this is horizontal, right? I have to apply a couple more constraints to make this fully defined. So in this case, I'm going to define, the diameter of the circle, kind of the length from here to here, and then the angle of the gear, and also the height. So we've applied some geometric constraints, right? That horizontal line there, or horizontal constraint there. But now we can do the rest with dimensional constraints, just like week 1. So over here, sketch dimension, and I'm going to start applying constraints. So 100. Again, your numbers don't have to be exactly like mine. I'm going to have this width here, maybe like 10. For the angle, I'm going to select this line and the horizontal line. Apply some angle. I'll do like 100 degrees. And then I'll have this height here. Let's make it 100 as well. So we'll see here, you see here, we have this half tooth here with this construction line. You'll notice that only this area is highlighted blue, because this is, a closed geometry. The circle fully encloses itself. And here, we have this construction line. It does visually close it off. But because it's construction, it is ignored when you go to extrude stuff, extrude or revolve, right? So you can see if I hover my mouse over this area, it doesn't get highlighted like it does over here. And that's because this is construction, right? So, in this case it's okay, because what we're about to do is we're going to mirror this, and then it'll close the whole thing. So that's what we're going to try to do. So to create this mirror here, to make this full tooth profile, there's this mirror tool right here. If you can't see it on the toolbar, you just go under create and mirror right there. And then it'll ask you to select objects and a mirror line. So in this case, we want to mirror this horizontal line and this kind of diagonal line. So for objects, I'm going to select these two. And then for the mirror line, we're going to use that construction line that we created. So select mirror line, click on that line, that construction line, and then we get a nice preview of that tooth profile. So this looks good to me. I'm going to select OK, and then bam, we have this full tooth profile. You can see now it's highlighted blue because creating that mirror fully closed this area, and now we have a nice tooth.
I had a question.
Sure.
How did you get like the angle? Yeah, like that.
This one?
Yeah, how did
Okay.
you get that?
So you're going to want to use the sketch dimension tool, just like you were doing for all the length ones that you were adding. But instead of just doing one line or one circle, you're going to click on two things. So in this case, I'm going to click on this horizontal line and then the diagonal line, and then it'll create an angle for you.
Okay. Okay, thank you.
Yeah, no problem. Any other questions? No? Okay. Again, if you have any questions, feel free to speak up or send anything in the chat. I'm happy to stop. We should have plenty of time today. I don't foresee us going over, so yeah. Okay, so now that we have our full tooth profile, right, we can edit it if we want to, right? So let's say we wanted to make this shorter, maybe like 80. You can see that the other half, because it's mirrored to the original lines we created, will be completely identical, right? So if I change this to 5, both of them move. If I change this angle, that goes with it, right? So that's good. That's what we're looking for. Now that we have this profile, what we can do is we can copy this and a pattern around this circle to make a gear, right? Typically gears, have more than one tooth, so we can do that now. So to do that, we're going to use the circular pattern tool. So there's the create circular pattern right here. And then similar to the mirror tool, you're going to select the objects that you want to pattern, and then you're going to select a center point instead of an axis or a line, like we did for the mirror. There's a couple ways that you can go about selecting this. You can click each line individually, right? In this case, it's not too bad because there's only like 5 things to select. But if you're selecting a bunch of different things, you can use, you can highlight it by dragging, or holding left click and then dragging. There's actually 2 different ways that the dragging tool selects things. And I didn't know this for quite some time. And when I figured out, it kind of blew my mind because it made selecting things a lot easier. So depending on which way you go when you're holding left click, it'll enable a different selection like tool or selection style. So in this case, if you hold and go like to the left and down, you can see it highlights kind of this yellow color. If you go the opposite direction, it highlights an orange instead, right? So if you go any way to the left, it's yellow, right is orange. And the difference is if you highlight something going to the left, if even just a part of the geometry is inside the rectangle that you make, it'll select that. So in this case, this is good because it's selecting, these 2 lines here, these 2 diagonal lines, and this construction line, right? So if I highlight left, you can see all of them light up. In this case, that's what we want. If I highlight in the other direction, it'll only select things that are fully inside the rectangle. So if I did it this way, it'll only select these 2 lines instead of the whole thing, right? So you see I did that there, and it only selects those 2 lines there. So that can be pretty useful depending on what you're trying to select. So it's a nice little nugget for you to remember. In this case, I'm going to go left and select everything. For the center point, I just want it to be at the center of the circle. So I'm going to click center point, click the circle, and then it'll allow me to specify how many teeth I want, right? So this right now it's 3. It's looking a little lacking, so let's do like 10. Okay, that's too many. Let's do like 8. Yeah, looks good. The distribution, typically people use full just because it evenly spaces them out, but if you had some kind of pattern where you only need it to go a certain amount of degrees, you can do partial, and then symmetric, makes it symmetrical. But in this case, full is perfectly fine. So when we confirm that, you can see we have a bunch of teeth now, and each one is a closed body, which is good. And then if I edit one of these, all of them change. So in this case, I moved it too much, and now they're overlapping. So I'm going to change this back. But you can see how being like quote unquote lazy in this case is good, because you only need to do it once and it affects all the rest of them. So that's kind of what we're looking for here. Does anyone have questions?
Yeah, can you explain why you patterned the geometry line too? Or the
I
construction
mean,
line?
you don't necessarily have to, right? I guess you could just not do it. Sometimes I just like doing it. In this case, when I selected it this way, it auto-selected, but you should be able to pattern it without it, without any issue.
Okay, thank you.
Yeah. Yep. Sometimes, like, this construction geometry is like a little bit more crucial, and in some cases, like not copying it makes them like a little bit weird. But for the most part, it doesn't really matter, because these are all fully constrained, and it's perfectly happy without them. Any other questions?
I had a question about the angle.
Sure.
I already had like my dimensions, I think constrained, so I made the angle driven. How do I change it so now the angle is the driver instead of and then I can like that would change the length of the lines.
So that means that there's some kind of over constraint somewhere. So either you might have to delete one of the like other dimensional constraints that you've already created, or you're gonna have to find some geometric constraint that might be preventing you from changing the angle, right? So like in some cases, if you draw the line too close to being perpendicular, it'll automatically apply like a perpendicular constraint. And then if you go to like try to make an angle here, it'll get over constrained, and it'll say if you want to make it driven, right? So then you have to figure it out. You can see here, there's this small perpendicular icon. You'd have to delete that, and then you can apply that angular constraint.
Okay.
Any other questions? I hope that made sense.
Yes, it did.
Okay, cool. Okay. So I'm assuming everyone's good here. So I'm gonna just finish the sketch. I'm happy with this. And then I'm gonna extrude it. So I'm gonna select all the teeth and that base there. Gonna extrude it to some dimension, maybe a little bit more. And there, we have this nice gear. Everyone good here? I'm about to go on a rant about holes, so I just want to make sure everyone's caught up. Okay. So I'm assuming everyone's here. So the next step in this assignment is to add a threaded hole. All right, so in this case, we're making a threaded hole, so it's typically a lot easier just to use like the hole wizard and the thread tool to create it. But in cases where you're just making some kind of straight hole with no threads, you might be tempted to, create a sketch, right? Make a sketch. Oh, I want a hole here. I'm gonna draw a circle. I'm gonna like dimension it to be like some number, like 30, and then I'm gonna extrude cut this, right? It's gonna go this way. Like it's gonna go through the whole thing. This looks good, right? And boom, yay, I have a hole, right? So in some cases, this is like technically correct, right? You might have achieved the geometry you're looking for. But there are certain reasons why this would be quote unquote like incorrect. Or at least it can be limiting when you send this part out for manufacturing. So Fusion has something, and many other CAD programs have some kind of hole tool or hole wizard, and it'll allow you to, create holes. I mean, it's kind of in the name. But when you use these tools, it actually gives a lot more information than when you just use some kind of extruded sketch. And that information can be really useful to someone who's manufacturing your part, right? So a lot of these CAD programs are not just for CAD anymore, right? They're called CAD packages. And it's because you can go from your design file into like some kind of manufacturing process all in the same program. So in this case, you might be designing some kind of gear and you want a threaded hole in the middle. So you want to be able to express as much information as possible to the person machining it. So, especially when you start to work in groups or in large companies, you're typically not, or the person who designs it is typically not the person who makes the part, right? So, if it was just one person and, you created extruded hole, you'd be like, oh, well, like, I know what that hole is. It's for this. And, like, I'm going to thread the hole later, right? But if you're sending this part to someone and they have a hole in there and they don't have all the information they need, they're going to be like, what is this hole for, right? Do I need to drill it with a drill bit? Do I need to ream it out for like a dowel pin? Or should I mill it out with an end mill, right? There's multiple ways of creating a hole, right? So you want to make sure when you pass on your part to the person making it, you give them as much information as possible. And one of the things you can do that with is by using the hole tool. So right here, there's this hole tool. So I'm going to select the hole tool. You can select, the face at which this hole is going to be made, and then it creates, a hole. In this case, I want it to be on the center. All right, so it's going to be here. But you can see here, can I move this? You can see here that there's a lot more information than before, right? So I think before I had like a 30 millimeter diameter hole or something, right? So, it would be 30, but there's a bunch of other options, right? You can even specify the angle of the drill bit, like the taper angle. So if this hole didn't go all the way through and you really need a very specific angle on the bottom of your hole, you can specify that here. You can specify the depth. In this case, we're going all the way through, so it doesn't really matter. So I can set this to all. But there's a bunch of other options for you to select, right? So this is just a normal straight hole, but you can also add counter bores or counter sinks, and you can add tapped holes. So in this case right now it's set to simple, so it's just a smooth hole, but you can make sure it's there, or you can specify if you want threads or not, like tapped or taper tapped, depending on your application, right? So in this case, we want a tapped hole. When we select that, you can specify if there's an offset or if it goes all the way through. And then you can specify, the thread pitches and stuff like this, right? This is all very valuable information to someone who might be machining your part. And a lot of this information could be lost if you don't use this kind of tool. Someone asked if we're supposed to have all the dimensions in millimeters. For this, it doesn't really matter. So if you're using imperial units and it's giving you like quarter 20 or like imperial thread callouts, it's not a big deal. Again, we're just mainly here to teach you the different tools. So mine's just set to metric, but if yours isn't, that's okay. But yeah, this is a lot of information here, right? And we wouldn't have been able to express all of this if we just created a hole using a sketch and extrude. So this is very nice to have when it comes from the machinist side. Also, we're not really going to be covering this in like this class, but if you were to make part drawings from your Fusion file, using the hole tool will allow you to kind of create callouts very easily. So when it comes to part drawings, you'll click on a hole that you created with the hole tool, and it'll say exactly what it is, right? It's like, oh, like use this drill bit of this depth, or like tap to this depth, or something like that. Where if you just use a sketch and an extrude, you're gonna have to do all of that manually. So using the hole tool can definitely save you time if you're making part drawings, and it eliminates a lot of work and it communicates a lot more information. So I know I kind of went on a long rant about this, but the reason why I rant about this is because it's pretty important. So yeah. Does that make sense? I know it's a lot of ranting, so. Yes? Okay, so I'm going to assume what I was saying is making sense to you all. But, now that we're in the tool, we can specify whatever we're looking for. So, I made it a tapped hole, created, they were specifying its diameter here, and then I'm just pressing OK. If you're 3D printing this, you can select modeled threads right here, and it'll just actually model the threads into your part. If it's not selected, it'll visually have some threads there, but it won't be modeled. And if you don't model the threads, it makes it a little bit easier on your computer because there's just less stuff for it to render. But if you're 3D printing threads, you want to make sure that the threads are modeled. So if you're wondering why your prints are just smooth, that's probably why. So model threads, you can see them, but it's a little bit more load on your computer. But yeah, that should be it for this assignment. Any questions about this?
Do we still have to color everything, or can we just submit?
It depends on the rubric. I forget off the top of my head if this one needs to be colored. I'm pretty sure it doesn't. But we can check. I always forget with this assignment. I don't know why. Yeah, so there's no like appearance applied thing for this assignment. So you're good if you don't color it. Same with the next assignment we're about to do. Any other questions? No. Okay. All right, so I think we're a little bit ahead of schedule, so we might finish early today. That's okay. So I'm assuming everyone's good on the gear. So we'll start on the air dryer assignment next. New part design. Okay. So for the hair dryer assignment, we're going to take a little bit of a different approach. Again, it's just mainly to teach you new tools and just to show you that there's more than one way of doing things, right? So when we're creating certain geometries, there's, several ways you could approach this. Just like the cylinder thing from week 1, you can make a rectangle and then revolve it, or you can make a circle and extrude it, right? For a geometry like this, you could do a revolve, right? You can draw this profile here and then revolve it. Or you can use something like a loft. So what the loft does is it takes a bunch of 2D profiles and then it combines them to make one nice, smooth, solid body, right? So using lofts can be pretty nice because it'll help you create more like flowing lines, which might be a little bit more annoying to create in sketches. So for something like this, a loft is a pretty good choice. But if you wanted to, you could revolve this instead. But, for this assignment, please use a loft because you're supposed to learn how to use it. So to create these lofts, or to create this loft, we're going to have to create several different sketches. The difference between what we've been doing before and just creating one sketch on the same plane is that we're going to create multiple sketches on multiple different planes. So to do that, we have to create 3 new planes. So by default, if I unhide the origin, also show the grid. If I unhide the origin, you can see there's 3 default planes that we can work off of, but for the loft, we want 3 more planes stacked on top of one plane. So they should all be parallel to one of these planes that we're working with. In this case, I recommend you create planes parallel to the top plane, just so the hair dryer's loft will be going upwards. But as long as it's consistent, it should be okay. So to create more planes other than these default ones, there's this construct dropdown, and there's a bunch of different plane types that you can choose from. So today I'm going to be using offset planes, and also I'm just going to show you what the mid plane does. But you can use 3 offset planes if you really want to. So I'm going to create an offset plane here. It's going to ask me to select some kind of plane to offset from. So I'm going to click on the top plane here. I'm going to have some distance, right? Maybe I'll do like 20. And then I need to create 2 more planes. So what I'm going to do is I'm going to create another offset plane. I'm going to make this one significantly higher than the other one. I'll do like 100. And then for the last plane, I'm going to do a mid plane just so you can see what it does. You select 2 different planes. So I'm going to select this one here and this one there. and then it creates a plane in the middle. So if I rotate, you can see these planes are all kind of stacked on top of each other, and that's what we're looking for.
How did you make multiple of them?
So you just go under construct, and then, either select offset plane or midplane. You select a plane that already exists. So in this case, if you're making your first one, select the top plane here. And then you specify some distance that the plane is offset from, right? And then you press OK. Any other questions? Okay, so I'm assuming everyone's good, or at least catching up on the planes. The next step is to create our sketches, right? So we're going to create 4 really simple sketches, right? We're just going to create 4 circles on 4 different sketches on each of the planes that we have just created. So I'm going to create a sketch. I'm going to specify a plane. So I'm going to start with the lowest one, which is the top plane. And then I'm going to start drawing my circles. So in this case, I'm going to draw a circle. I'm going to make sure it's centered on the origin. And when I draw future circles, I'm going to make sure they're also centered, right? So again, this is kind of going back to good practices because it'll minimize your work later. So that looks good. It's fully constrained, right? It's white or black if you have the light theme. I'm going to create another sketch, but instead of selecting this plane that we just were on, we're going to select a different one. So I'm going to do the one that's just above it. I'm going to draw another circle on the origin. This time I'll make it a little bit wider, maybe like 80. And then I'm going to do it 2 more times on the other 2 planes. So there. This one, I usually like to go somewhere in the middle, so I'll go like 65. And then for the last one, I'll go, let's go like 70. So once you're finished, you should have something that looks like this, right? If you orbit around, you can see they're all on different planes, which is what we're looking for. Everyone good here? Yes. Everyone good? I guess so. Okay. So with all of these sketches created, we're going to create our loft here. So we're going to go under create and loft, which is right here. And then we're going to select the profiles to loft. You want to make sure you select them in the order that you want to loft them, because if you don't, then it might turn your loft like inside out and it'll do a bunch of weird stuff. So, if you do it wrong, you might select the bottom one, and then you click on the middle one, and then you click on this one, and then you go forward again, right? It's going to look like completely whack, and this doesn't really look anything like what we were going for, right? So we need to make sure they're in the correct order. So I'm gonna click this one, and then that one. And then we have this nice hairdryer head. If you want to adjust it, you can change like some dimensions, like this. And you can even change the planes, right, to extend certain things, right? Like we can make this 120 and make the hairdryer taller, right? This looks good to me. It should look like a vase. Anyone need help here?
Yeah, I'm getting a weird error saying something about the rails.
Something about the
Yeah,
rails.
let me see.
Are you using guides on accident and not selecting profiles instead?
Oh, maybe that's what it is. Let me try again.
Yeah. If it's not working for you, sometimes it's easier just to like either delete the loft or the feature and then just redoing it, just so it like resets some of the selections to default.
Okay, it worked now. Thank you.
Okay, sweet. Okay, so now that we have this, our next step is to make it hollow. So we're going to use the shell tool to hollow it out. So to do that, there's the shell tool right here. And then we just click on a face that we want to be open. In this case, I'll click on this one here. And then we specify some kind of wall thickness. So maybe like 4 millimeters in my case is okay. Maybe like 3. So when I specify that, you can see it hollows out the inside. And it has a constant 3 millimeter width all the way through. So that's definitely very nice, especially for something with a more organic geometry like this head here. Because if we tried to revolve this, then we would have to, draw every single arc, and that definitely can get annoying and tedious. So the shell tool is pretty powerful. Any questions about this?
What does the shell type do?
Shell type?
Yeah, like the rounded shell.
I've actually never really used the rounded shell, but I'm assuming like if you're creating some kind of like if you're shelling out kind of like a more square feature, it'll kind of create little fillets on the corners. In this case, like it's a pretty organic geometry, so it doesn't really seem to make much of a difference. But I'm guessing that's what it does.
Okay.
Yeah. I usually just use the sharp shell for everything, but this might be useful depending on your use case. Any other questions? Okay, so now that we have this, we need to add a fillet on the outside. I'm purposely gonna do the fillet incorrectly. I'll walk you through how to do it correctly, and I'll explain why I'm doing it incorrectly in a little bit. But basically, we're gonna create a fillet. You're going to want to fillet just the outer edge and not both the outer and the inner edge. I'm going to fillet both, and I'm going to show you why in this case it's not a great idea. But you should just do the outside. Or you can do both and then fix it with me when I get to that. So I'm going to apply 1mm fillet. Looks good to me. Or it's technically wrong right now, but we'll go fix that later. Okay, so now we have the fillet. We're gonna need to also add some kind of handle. So what I like to do for this is I like to create a plane that extends beyond the hairdryer, and then I like to extrude it both ways. So this deviates a little bit from the slides. Personally, I think it's a little bit cleaner. But again, this kind of shows there's different preferences when it comes to CAD. And, you know, they may or may not be like, or there's no like wrong answer in this case. I definitely recommend this method a little bit more, but either way works. So what I'm going to do is I'm going to create another plane. I'm going to create an offset plane that extends beyond the hairdryer's body. So I'm going to select this plane here, and then I'm going to make sure this plane extends farther than the hairdryer, right? So if I look from the side, the plane is here. I'll exaggerate it a little bit just so you can kind of see what happens when I added stuff to it. And then I'm going to create a sketch. So I'm going to sketch on the plane that we created, and then I'm going to draw the handle. So I'm going to just extrude a circle. So I'm going to draw a circle. I'm purposely going to make it like offset from where I want it to be. In this case, I want it to be aligned vertically with the origin. So I'm going to shift click the center point of the circle and the origin. I'm going to add a horizontal vertical constraint, so I can't move it side to side now, right? And then I'm going to apply some dimensions. So let's make this 30, and then let's do like 40 for this one. So we have this nice fully constrained sketch that's sitting outside of this hairdryer. And now I'm going to extrude it. So I'm going to go under the extrude tool. I'm going to make sure this profile is selected. And instead of the direction being one side, I'm going to set it to two sides, right? So I'm going to want to extrude it in this direction so it combines with the hairdryer's head, but I'm also going to extrude it in the other direction to make sure it's, you know, long enough for someone to hold it. So two sides. For the first one, you can see the arrows highlighted blue depending on the direction. So side one is always blue in this case. So instead of it being some arbitrary number, we want it to go straight up to this head or this body right here. So instead of distance, we can do to object. And when we select a certain object, it'll basically extrude around up to the face of the object we select. So if I click on the hairdryer's head, you can see it extrudes, and this body is a complex curve, but the extrusion will just mate up to it, and it doesn't protrude onto the inside, right? It just goes to the outer surface and wraps around it. So that's kind of what we want for this. For side 2, we can have it as some arbitrary number because there's no surface for it to mate up to. So, we can just drag it out. Maybe 120 looks good for this scale. You can see this blue circle here, right? That's where we created the sketch. And you can see the two kind of gray areas based on the side of the sketch or side of the extrusion we've created. For this operation, we want it to be joined because we want this to all be one piece. So I'm leaving it as a join, and I select OK. Does that make sense? Does anyone want me to do it again? No? Everyone got that?
I had a question on one of the options
Sure.
for extrude for side 2. There's
Mhm.
there's a small little button underneath, I guess there's two extend buttons, and one says to the selected face, and then there's an option to adjacent face, and it shows a red line, but I can't tell what the difference is.
Oh, the extend to selected face or adjacent face.
Yeah, does that change anything significantly?
On this one, I don't think it does, just because it's kind of one continuous curve. But you can kind of see if there was kind of what do you call it? If there was kind of a sharp angle, you can kind of select or you can have it extend just to go kind of straight onto something, or kind of wrap around it. In this case, because it's so curved, I think it just wraps around everything by default.
Gotcha. Thank you.
Okay, any other questions? All right, cool. So the next thing is to add a chamfer onto the end of this. So I'm going to go under Modify and Chamfer. I'm going to select this edge right here, apply some dimension, maybe like 8 or something. Yeah, looks good. And we have, this hairdryer with a handle, right? So your model should look something similar to this. Currently the handle is solid, but let's say in some cases you want this to be hollow as well, right? Maybe you need to fit some electronics inside, for the little switches and stuff like that. And you wanted to kind of shell it out as well. So one of the cool things about Fusion and a lot of other CAD programs is you can move the features around in either the timeline or whatever, to kind of create the operation in a different order, right? So in this case, this timeline is pretty straightforward. We made a bunch of planes here, made a bunch of sketches, we created that loft, and then we shelled it out. We added that fillet, more planes, and then that extrusion and chamfer, right? But we have the ability to change the order to change the model, right? So let's say we wanted this handle to be shelled out, right? We can make sure the shell happens after the extrusion, but we can only do that if there's no dependencies. So, you might remember earlier that I said that I'm going to purposely do something incorrectly. And what I did was I created a dependency in this case, right? So for this fillet here, I filleted both the outer and the inner edge, but this inner edge can only exist if the shell exists, right? So typically, if you can move certain features, you can drag it along the timeline. But if I try to drag the shell, you can see there's kind of that white line that ends right before the fillet. And you can see my mouse is still moving to the right, but it's not moving the feature at all. And it's because this fillet is dependent on the shell, right? It needs the shell to exist before the fillet for this to be possible. So I can't move this. So in order to move it, I have to remove that dependency. So I'm going to have to remove that inner fillet I created. So what I'm going to do is I'm going to edit the fillet. You can hold Control to highlight the lines that you selected, or arcs. So in this case, it's this one. I deselected it. I'm going to confirm it. And now, if I try to move the shell, you can see it moves, that white line moves with my mouse, right? I can move it all the way to the front. And when I do that, if I look very carefully, you can see the inside of this handle is also shelled out, right? I didn't change, or I didn't add any more features, but I've created, a different kind of geometry internally, right? So the order of which you create your features can sometimes be important. So it's a good thing to keep in mind when you're modeling things. If you need certain geometry to be flexible, then you might want to make sure that some things aren't dependent on it. One of the things I find myself doing often is like with all the chamfers and fillets, I typically add them at the end because they're usually not super critical to the geometry, and they're just kind of there to, make things look a little bit better. But when you have them in the middle of your timeline and you want to move things around, sometimes it can kind of create dependencies, right? So typically I like to put my fillets and chamfers at the end, just to make sure I can move and change things in the timeline a lot easier, if that makes sense. So it's just all these little things that, you might pick up over time, and it makes your models a lot easier to, troubleshoot and modify later. Or does anyone have any questions about this? The dependency thing is, like, in my opinion, pretty important. So if you can understand that, it definitely will help you in the future.
I just have a question for the rubric.
Sure.
Do we have to have the shell done after at the end, or does it matter where we do the shelling for the
I mean,
rubric?
I'd recommend you do it in this order. Honestly, when I'm grading, it's going to be very hard for me to like see if you shelled the inside or not, depending on, the orientation of your screenshot.
Mhm.
So, if this thing is solid, it's not that big of a deal. But I hope that you can at least take this information away, like, because you're in class and you can understand this concept, because it's definitely useful for other things.
Okay.
Any other questions?
For me, I moved the shell like you did, like to the very back, and I can see that it's completely hollow. But now, like the top of like the dryer now has like a lid, which like it's not. I don't know if
Oh,
I just
like
need
the
to get
top
that
here
line.
is like solid?
Yeah, it's solid.
Oh, interesting. Um, so if you edit the shell, the face that you select should be this top face here. Oh,
Mm-hmm.
well, I wasn't trying to do that, but you should be selecting like this top face. Is that what you selected?
Yeah, and it shows it like when I do go to edit the feature, the face is there. Like it makes like the highlight, but when I press like OK, then there is still like the solid face. But
It's
then underneath like the shell,
strange.
I can see if I select that, I can see like it's fully throughout like the rest of the dryer. I don't know.
That's very strange. I might have to like look at your screen a little bit later if that's cool with you.
Yeah.
Okay. Yeah, we can do that after because yeah, we still have like half an hour and we're about to be done here, honestly. Okay, so I'll get back to you on that. Why don't we finish this wire and then I'll go over the homework and then we can take a look at that. All right, so now that all of you have this, we're going to create our wire here. So what we're going to use is the sweep tool, and it's kind of similar to a loft where you have multiple 2D profiles to create some kind of 3D thing. So what we're going to have is we're going to have kind of like a path for some kind of profile to follow. I believe Fusion references it as like a path and a profile. So the path that we want is going to be like this kind of line and arc combo. And then the profile is just going to be some kind of circle because like wires are typically pretty round. So I'm going to start with just that circle. Or actually no, I'll start with the path. So I'm going to create a sketch. In this case, it's going to be this right plane here. And because we created all of this centered on the origin, it's basically, you can see this like grid, it's slicing the whole hairdryer down the middle, which is kind of what we're looking for, right? So it's nice and symmetrical. We're going to want some kind of wire path coming out of the center of here, but sometimes it can be kind of hard to pull the geometry off existing faces. So what we can do is we can project geometry from some existing face onto our sketch, right? So to do that, you just press P, which is the hotkey for project, and then you can select some kind of geometry, right? So in this case, I want to make sure that the path is centered on the circle here, or the cylinder here. So I'm going to select this circle, like this outer edge of the cylinder, and then when I press OK, you can see that it projects this circle onto the sketch, right? And then from the perspective of the sketch, that circle is actually just a straight line. If I hide the body, you can see it creates this purple line, which is a projected line for us to reference, right? So we can use this and draw off of it. I'm just going to keep the body hidden just so you can see it a little bit better. So to keep it centered, I'm going to make sure I'm on the midpoint of this line. You can see it kind of snaps there with that triangle icon. I'm going to draw a nice straight line out here. And then I'm going to create an organic looking wire by using the fit point spline. So it's right here. Select this starting point and then I just kind of click my way down. Creates this nice organic looking wire. I'm gonna click the check mark. These green lines are there to like allow you to manipulate the spline, right? So you can kind of move it around if you want. I'm gonna just leave it like unconstrained, just because it's just easier that way. And you know, this is kind of organic and doesn't need to be that precise. But I do want this transition from this straight wire to this kind of spline area to be nice and smooth. So I'm going to create a tangent constraint between these two. So tangent, select U and U. Now there's a nice smooth transition. So that's what we're looking for. If I show the body again, it should look something like this. So this looks good to me. The next step is creating that profile. So I'm going to make another sketch directly on this face here. And then I'm going to draw a circle. So it kind of automatically gives me the center point, but if you want to be extra careful, you can project, you know, the outer circle here. Give you a nice target to hit. I'm going to draw a circle here. Maybe it's a little too small. Do like 5. And now we have this profile here. So that looks good to me. The next thing to do is to actually create the sweep. So you go under Create and Sweep, which is right above the Loft tool that we used earlier. And here, again, it asks to select a profile and a path. So in our case, the profile here is that circle that we made. So I'm going to select this one here. And then the path is, you know, that squiggly line we made. So I select that. And then bam, you have this nice wire profile. Select OK. There we go. We've created this nice wire on our hairdryer. Any questions on this sweep?
Yeah, could you just show how to do the sweep one more time?
Sure. So I just deleted the sweep. If you ever need to show your sketches again, you can just go under the Sketches tab and like un-eyeball them. I'm going to go under Create and Sweep. Here it's going to ask for a profile, so I need to select that small circle we made. And then the path is going to be this organic line that we made right here. And you just press OK, and you're good to go. Sometimes it won't want to generate your sweep if like the angle of some of these lines are too extreme. So like make sure that this is nice and tangent, and make sure these aren't like too crazy, because then sometimes it might get mad at you. But yeah. Is that good? Hopefully.
Yeah.
All right, sweet. Any other questions for this assignment? Okay. If there's no questions, then we're just about done. I'm going to go over the homework real quick because personally I think this is one of the hardest assignments in this class. Just because, you know, there's a lot of minute details that you need to get get down to, have a good submission for this. So, okay, so your homework for this week is to utilize, all the new constraint tools that you learned, along with the dimensional constraint, to create, a fully constrained drawing. So I know last week I said dimensions don't matter in this class, except for like 1 or 2 assignments. This is the assignment I'm talking about. So I want you to basically recreate the sketch that I'm going to show you one for one as your homework. Because, creating really strong and robust sketches is a really important skill to have when you're designing things, because it's kind of the foundation of all your designs. So if you can do this well, then you're going to be pretty set for most of the things that you're going to be drawing up. So what I'm asking you to recreate is basically an extrusion profile. So if you didn't know, there's a bunch of standard extrusions that you can buy, either on the internet or at the store. And they typically look something like this. They have these kind of inner geometries here, and it actually allows you to put in hardware like nuts and bolts to kind of create like frames and stuff. So some people make like workbenches and stuff out of these extrusions. I build 3D printers out of these extrusions. So they're a very versatile kind of piece of hardware, and it's really great for prototyping. But one of the things about them is that, the sketch can be a little bit complex. And if you can create a sketch like this, then you should be able to create a lot of pretty awesome sketches. So basically your goal is to recreate this sketch using the dimensions given. So you should be able to create this whole extrusion with just the dimensions that are provided. In this case, it's kind of a lie because this is actually missing a couple. So you should be referencing this sketch here. So this sketch also kind of gives you a hint at how I personally would approach this kind of sketch. You want to make sure to kind of simplify it as much as you can, and then, add that complexity back later. So you can see here, I created this kind of half profile of the extrusion here, and then once this is fully constrained, you can mirror it and then pattern it, just like we did for the gear assignment. So I would highly recommend you approach this assignment in this manner, because there's a lot less geometry for you to lock down and fully constrain, and your computer will be happier. If you like mirror and pattern all of them and then continue to constrain all of it, your computer is going to lag a lot more, unless you have like a super awesome computer, which I do not have. So I recommend you kind of approach it in this way. You can also see that I've created some construction geometry here, right? So I've created this kind of square, right? So, these two lengths are kind of equal. This was created in another program, so if you we're going to try to steal this, you can't, because this is, not made in Fusion, and I'd know. But it can kind of give you some hints as to what constraints that this thing has, right? So you can see here, this horizontal line here means this line is horizontal. This thing here means it's equal to something. In this case, it's equal to this line here. And you can see like tangent constraints, other equal stuff, right? So you should be able to create the sketch here, make it fully defined with all the dimensions placed here without adding them more than once, right? So if I see you have like 2.9 in 2 different places, you're going to be losing points, right? Because if you have 2.9 in 2 different places, it means you could have had an equal constraint, right? So again, this is a big hint to what your sketch should look like before you mirror and pattern it, because you know, all these lines are fully constrained in this image, right? You can see point 1 is only mentioned once because all of these radii are the same, and all these dimensions are only laid out once. So again, you should have a sketch that looks very similar to this before you mirror and pattern it. But yeah, that's basically your homework assignment for the week. Again, if you have any questions about this, please reach out. It is, in my opinion, one of the harder assignments for this course, so I'm happy to help if there, is some confusion. But yeah, that's kind of about it for this week. So unless you have any questions, we can wrap it up. I guess, yeah. The other thing to note, or I'm assuming you know this, but your final sketch should look like this, like with all 4 corners. When you submit the assignment, please submit the sketch open, right? I want to see all your constraints and all your dimensions. So don't, exit the sketch or like, extrude it or anything, right? I want to see the sketch open, right? Because that's kind of the point of this assignment. So please, make sure your sketch is open. Should look something like this, finished sketch in the top right corner, that kind of jazz. So yeah, if you don't do that, then you're going to lose points because I won't know if you fully constrained it or not. So yeah. Any questions?
What are the units for this? Is it in inches or does it not matter still?
Units doesn't matter as long as the numbers are correct. So, if it's in millimeters or inches, it's okay. Just as long as the numerical values are the same.
Okay, thank you.
Any other questions? Okay. Well, if no one has any questions, I guess I'll see everyone next week. Again, if you happen to have questions after, I close the Zoom, feel free to message me or message the Discord. I can try to get those questions answered. But if not, I will see everyone next week. I'll stick around a little bit till around 7:30 or a little bit later to help anyone out. But yeah, I'll see you all next week.
Good night. Have a good night.
Thank you.
See you later. Okay, let me